What happens when you try to set ice on fire? Shockingly, it doesn't work. So here's an idea, what if we put gasoline on it? The ice is burning. Or is it? Shockingly, the ice is melting. And also, if you put ice in water, it raises the water level. Shocking. So the question is... So for us to find out, I'm going to need some new ice. Because I'm recording this like 2 months later. And the ice outside has melted. Rest in peace, Hassan. Anyway, we'll check on this later. Okay, so while we wait, I'm going to prepare the things we need for the experiment. We're going to need a clear container so we can clearly see the water level. So I cut a plastic bottle in half to make this cup thing. Then, after filling around half of it with water from our fountain of youth, I marked the base water level so we can see how it changes. All we need now is to wait for the ice.
Ice. Experiment. Wait.
Once the water became crispy, we could actually start the experiment now. All we need to do is take our ice, put it in the container, and mark the new water level. This way we'll see if the water level changes or not when the ice melts. Now I'll just set this bad boy down on the floor and we'll check it out later to see the results. And while we wait, I'm going to give you a quick physics lesson so we can actually understand what happens.
Changes when the ice. Wait for it to melt. I can see you.
The thing that makes things float is buoyancy, right? Gravity pushes down, but buoyancy is just the water pushing up. And if the water pushing up equals the weight pushing down, then it cancels each other out and it floats. And how does water even push? Well, let's say I put a toddler in water. The toddler pushes the water away. This pushed out water pushes the toddler back. So the bigger the toddler and the more water it pushes away, the more water will push back. That's why even metal ships can float. They sink until they push enough water out so that enough water will push them up.
Hello, it's me, a member of your species.
Huh?
It's time to eat dinner.
My species? What is that supposed to mean?
No, it's me, your family member. Please come out now, I'm hungry. Please come out so I can eat you. I meant dinner.
Something's not right, it's just repeating things.
Ice experiment.
Okay, that couldn't be more obvious. It's fortunately just a mimic.
Please come out so I can eat. Hello.
Pineapple!
Pineapple.
See, it is a mimic, so that's what the noises from the bushes were. So let me follow my special procedure.
So let me follow my special procedure. I'm hungry.
So it's about time to check the ice now. It's been exactly 27 hours, so the ice should be melted by now. Oh, shucks, guys. All the water evaporated. Just kidding. It's right here. I covered it in foil, just in case. I am a professional after all. And now for the result. Did the water level change? No. But why is that? Okay, so the buoyant force depends on how much water is pushed out the way. It depends on the volume and the density of the liquid. And did you know that volume times density is actually mass? So the buoyant force is dependent on the mass of the water displaced. In Uga Buga, think push, push same pushing, because same heavy. And boom! The water level doesn't change. So that means The icebergs in the ocean, if they melt, they will not raise the sea level. But what will raise the sea level, as you learned today, is if the ice on land melts and then that water goes in the sea. The more you know. Well done. Yeah! Remember to not leave gasoline on the floor!